In this video, you will learn about the famous hole in the ozone layer and why it has got thinner. We will also look at the action the world has taken to restore it back to health. To find out how stratospheric ozone is made and how it stops harmful UV from reaching the ground, view Part A of this video. In the 1980s, scientists found something alarming happening over Antarctica during October when the sunlight returns to the South Pole after winter. The ozone had almost disappeared over large areas, causing the famous hole. An aircraft which analyzed the composition of the air flew due south 15 kilometers above the Earth in the stratosphere where the ozone is most concentrated. They found that the ozone there suddenly became replaced by chlorine oxide. This led to the realization that the chemicals called CFCs, chlorofluorocarbons, were to blame. These are inert, stable molecules and were once the wonder chemical used as the fluid in fridges and air conditioners, to expand polystyrene, and in aerosol cans to propel hairspray and paint and so on. They were completely harmless to animals. So what went wrong? Well, CFCs are so inert that they do not get washed out in the rain or broken down in the troposphere, so they diffuse up into the stratosphere. Use your knowledge about how ozone is formed to think about what might happen to CFCs in the stratosphere. Pause and think. Here they are bombarded with ultraviolet light, which breaks chlorine atoms off the molecule. These then bond with the free oxygen atoms, preventing them from reforming ozone in the ozone-oxygen cycle we saw in the first part of this video. When the chlorine oxide meets yet another oxygen atom, molecular oxygen reforms, leaving the chlorine atom to continue to remove more atomic oxygen. These chlorine atoms are eventually removed from the stratosphere naturally, but not before they have captured thousands of ozone-forming oxygen atoms. Thus the ozone-oxygen cycle was being destroyed, and the ozone layer was thinning all over the world. Thus, in 1987, the Montreal Protocol was signed by all nations of the world, banning the production and eventually the use of CFCs. They have been replaced by HFCs, hydrofluorocarbons, a similar molecule which contains hydrogen in place of chlorine, making them a little more reactive and so able to be broken up in the troposphere before they reach the ozone layer. Because the chlorine is slowly and naturally removed from the stratosphere by complex photochemical reactions, and because the ozone layer is naturally reforming all the time by the action of UV on oxygen, we expect the ozone to return to its original level in 50 or 100 years' time. The hole in the ozone layer allows harmful UV radiation to reach ground level, which can cause skin cancer. However, a common misconception is that it lets heat in and causes global warming, and this is not true. Ozone is also generated in the troposphere by a complex series of photochemical reactions on the products from vehicle exhausts. Here, in the troposphere, ozone acts as a greenhouse gas and helps in the formation of photochemical smogs that pollute certain cities worldwide from time to time, for example, Los Angeles in the USA and Beijing in China.